Let's touch a little, little bit more on the permafrost here in the context of methane and feedbacks. Of course, you remember polar amplification, and the peatlands and the permafrost are at high latitudes, which obviously is something worrisome if you have accelerated warming over those regions. So we will see the Arctic warming in a second. Obviously, that creates warming of the permafrost and thawing, which would actually expand wetlands. You would get more water from melting the frozen soil, but lakes would drain and then soil can dry. I will show a picture in a minute. That would change the CO2 efflux and also the methane efflux, which would increase global warming. So you have a positive feedback loop over there. And the permafrost thawing also enhances microbial activity in the soil. It's warmer is always more favorable for microbial activity, but you also have lots of organic matter in these soils that are frozen, and as they warm and thaw, that's going to feed a lot of microbial activity as well. That's going to enhance nitrogen and lead to enhanced shrub growth, so that would feed back to the drawdown of CO2 and have a negative impact, and you would potentially sequester some carbon. So the question really is, what's already happening with the warming that's already manifest through the latter half of the 20th century, especially after, let's say, 1980 into the 21st century, and the polar amplification, what's happening. So actually there is a little bit of a debate about it. So this is a typical thawing of a permafrost region. You can see that you end up having these puddles which have complicated dynamics, as we see here, and the general idea is that when you have thawing and create unfrozen grounds, you enhance microbial activity. So driven by greenhouse gas emissions, Arctic temperature has definitely increased by about 0.6 degrees centigrade just since the 1980s. So that's tremendous amount of warming. Warmer air thaws the ground, thawing some of the frozen permafrost, which contains, by all estimates, 1,035 billion tons of carbon locked up in these permafrosts. So that's going to be releasing lots of greenhouse gas, and thawing of the permafrost allows microbes to decompose the organic matter in the soil as well, and this releases even more greenhouse gases, which in turn enhances the warming. Is that really what's happening? Is this a ticking time bomb? It turns out that this paper here by a USGS author actually argues that it's not really that much of a ticking bomb. So he's showing various estimates of projections of cumulative emissions of petagram carbon from permafrost for 2100, 2200 and 2300, keeping in mind the warming over the Arctic, as we said, 0.6 degrees. This is the change in annual average high mountain permafrost temperature, and this is the change in annual average continuous Arctic permafrost temperature. There is warming, no doubt at all. The question then is, how much more carbon is it going to release? So we can think of CO2 equivalent and combine methane and carbon dioxide with all the feedbacks to microbial activity and so on. Also the puddle forming, draining of the lakes, drying of the soil, shrub growth, etc. So here the authors say, we find that the current evidence suggests a gradual and prolonged release of greenhouse gas emissions in a warming climate, and present a research strategy with which to target poorly understood aspects of permafrost carbon dynamics. Okay, so I'll come to the wildfire in the next podcast, but we wanted to close out the methane CO2 discussion with the permafrost thawing, because for a while it raised a lot of concern. There were lots of concerns that this is a potential place for accelerated global warming and no analog state of losing all the permafrost with a positive feedback between the thawing of the permafrost, release of carbon dioxide and methane, enhanced warming, polar amplification, and so on, right? So theoretically, it does make sense that such runaway warming can happen. So the question is, based on the evidence and the best modeling abilities we can bring to look at the future of carbon emission from the peatlands and permafrost, including the mountains and so on. Is it going to be much larger than the emissions we are expecting from other human activities? Okay, so the review article from Nature that I just showed with fluxes for the future argues that actually we are not really much more beyond the range of what we expect from human activities. So just to make sure you got the numbers, in 2100 the numbers range from less than 50 petagram carbon to more than 100, almost 180 or so with some uncertainty. So these are the two estimates that are pretty high compared to these. And of course these are long-lasting impacts, and the feedbacks could go on for a while, especially if you begin to lose sea ice or if you have lost it, and albedo changes and so on. You have to also look at longer time horizons like 2200 and 2300. I will just mention something here that you may or may not fully comprehend. When we do projections, let's say we are in 2021 now. Wow, really? Out to 2040, 2080, 2100. In the shorter term, out to 2030 and 40, the uncertainties in projections, like these envelopes you would see in the projections as well. This is the uncertainty in the observations here, and this is the uncertainty in the mountain observations as well. So the uncertainty cone that we have depends on model uncertainties in the short term, but in the longer term we make lots of scenarios, as we mentioned already, for population growth, technology, energy mix, carbon capture and sequestration, and so on. So it's these uncertainties in the scenarios that begin to dominate the projections for 2100 and beyond. But still, there is fundamental science in it, because we have life cycle and residence time of carbon that's going to matter in terms of how much warming we are going to lock into the system by emitting all this carbon, which in fact we have already emitted since industrial revolution. So each additional petagram of carbon is going to have additional warming associated with it. So any reduction in carbon at any time, at any place on the planet, is going to have an impact on the warming, a beneficial impact, right? And hence beneficial impact on the high latitude processes like permafrost thawing as well. So just make sure that you keep that in mind.